So we're going to flip the inequality because we're dividing by a -4. So this is going to flip. And then 10 divided by -4 is negative 2.5. So not a terrible decimal, but also obviously not a whole number. Maybe makes you question if your answer is right. Because if you actually did a step wrong, it's possible you got a nicer answer than we got. So if I go to put this on my number line, it just requires that I have to put a couple other values. So something smaller and something bigger as well. So smaller would be -3, bigger would be -2. Or you could do -1.5 and -3.5. It doesn't really matter as long as you put another couple values on there for me. Then it's an open circle.
No, that is 2 whole numbers and then a decimal.
Oh, that really bothers you?
Yeah.
Yeah. Well, but the thing is, that is right in the middle, but yes, it's giving you like, making it twitchy, sorry. So, then we need to go bigger again, and the reason we have to go bigger is because we flipped the inequality because we divided by the negative. So just be careful with that as you guys are going through these. All right, so we're going to talk about today our compound inequalities. It's really not that much more difficult. Just makes you be able, it requires that you're a little bit more organized maybe. So you want to make sure that you're kind of staying nice and neat when you guys do things, nice and lined up. So again, this is our last thing we're doing before spring break, obviously, because you guys we're virtual tomorrow. That means we're not going to see each other for almost a full 2 weeks. So we won't have this for 2 weeks. So just that you guys are aware, I will come back anticipating that we're going to probably be a little bit rusty. We'll have to review a little bit. I'm trying to think what we come back and do, but I feel like it'll be an okay transition. So just that you guys know, but hang on to your notes so that you guys don't forget everything, or if I ask you to refer back to something that you have them. So I realized the people online didn't get our answer key, so I'll pop that up quick. So this is the answer key from last time. All right, so we will get going on our notes here. We'll probably do, ready to fight you. Come at me, bro. All right. All right. Sorry, yeah, I put a couple there already. I almost forgot to keep record. I got about halfway through the warm-up. Oh, no. So, all right. But I caught myself. All right. So, and compound inequalities are what we're going to be talking about today. And this actually does come up pretty often in our real life, where we talk about, to be in high school, you have to be in a range of ages. At some point, they're going to send you away from high school. Even if you're like a 5th or 6th year senior, there's a certain point where we just don't want you in the school anymore if you're 21 years old and can like buy your friends alcohol or something like that. I don't know. So they stop allowing students to go to school at a certain point. But in order to be in high school, you have to be a certain age as well. So this is a range of values that we can talk about that in terms of a compound inequality. So it's kind of 2 inequalities to go with this. So if I'm looking at this in terms of a number line, I'm going to put 13 on the left side of my number line because that's the smaller number. And then I'm going to put 21. Now we want people, or most students that I'm going to like survey, unless they're like child geniuses or something, if I surveyed most students, they would be in that range of values. So what we say then, you must be at least 13 years old. So do you guys think 13 is included? Would you agree that you could be 13 in high school? Okay, so we're going to include that. And then cannot be older than 21. So I think the day you turn 21, and actually these notes are from my previous school, and we don't have this at Random Lake, but we had a classroom we called the apartment for students who had special needs, that had things like Down syndrome, or like had more severe special needs. they could go to high school until they were 21, and then they had to go to a different situation. So the day they turned 21, usually the day before, we had like a little like celebration. They were kind of moving on from the high school situation they were in. So this is our range of values. So what we're going to do to show that on a number line is we're going to draw a line between it, because any ages between there would work. So if I ask you and you say I'm 14, I'm 16, I'm 18, you are in that range of values that makes sense for a high school student. Now to write this as an inequality is kind of weird. What we do then is we put the variable in the middle. So I'm going to use A for age. And I'm going to compare 13 and 21 to that age. So I'm going to put that variable in the center, and I'm going to put numbers on either side. What does A need to be compared to 13? Is A greater than or less than 13? Yeah. Greater than or equal to, because A, it could be a 13 or above. However, there's a limit to that. So again, we have to stop at 21. We can't send the students anymore at 21. So what does A need to be compared to 21? Yeah. Yes, so less than. So this is considered this compound and inequality. Both of these things have to happen. You have to be in that range of values. Okay. So we're going to talk about how to solve these compound and inequalities here today. What's he doing? Is he escaping?
Escaping.
He's
Literally escaping.
He had all his feet off the ground. Buddy, you can't get out here. He's like, whatever, Mom.
He was literally escaping.
Well, because normally that's where his filter is, so like that spot's normally not
And
empty.
he found it.
Those of you guys not here, we have my turtle is in the classroom, and he's trying to escape from his tank. So yeah, he'd venture out and let him out later. He'd go on a walk with us.
Do you have a leash?
No, he's not that fast, Mrs. Miller. I could catch him pretty fast.
For a run with him?
All right. So now we're going to solve this compound and inequality. So talking about this is we want the variable to be alone in the center. So we're going to isolate the variable in the middle. So what we're going to do is we're going to undo what's happening to the variable in the middle, and then we're going to do that to either side of the inequality. So it's almost like there's three parts of this inequality. So it helps to kind of draw like border lines, because that's our three different parts. And we're going to use the same steps we normally do, but whatever we do to the middle, we're going to do to either side. So what would I do to get x alone in the middle? Yeah, what do you think? Yeah. So we're going to subtract 6 here in the center. Now if I do that in the center, I have to do it to both of the numbers on either side of the inequalities. So I'm going to subtract 6 here and also here. So you're doing it like 3 times. Now if you look at the book, I believe the book does 2 different equations, like so they take it and they write it as 2 separate inequalities. I think if you stay organized, this is really doable. But if you're not a very organized person, or if you're not very good at writing vertically in a straight line, you might want to set these 2 equations up. So now in the middle, I just have 3x. Now the inequalities get to stay the way they are. Then here, so 21 minus 6, I get 15. Subtract. And then here I get 60. And then to get x alone in the center, what are we going to do? So it's being multiplied by 3. So we're going to divide by 3. But if I do that in the center, I have to do it on each side as well. And there's no flipping of inequalities in this case because we didn't multiply or divide by a negative. So that multiply and divide by a negative rule still like holds true. It just, we haven't done that. So this is 5 and this is 20. So here's our compound inequality, our and inequality. So now we need to put that on a number line. We need to go from smallest to largest. I'm going to put my 5 and 20 on there. I don't need all the values in the middle. I assume you know what comes between 5 and 20. If you want to put a bunch of different values in the middle, you're welcome to, but you do not need to at all. What kind of circle do I put at 5? Non-filled in, yep, so like the open circle. And then at 20, it has that equal to line, so I'm going to color this in. Now, and inequalities are always going to kind of look the same way. They're going to kind of look like a little bridge because x is bigger than 5 but less than 20. So it's in this range of values where numbers would work. Sorry. So between that range of values. So if I picked a number in the middle here, it would work in this inequality. So if I picked 15, it would work in this inequality. Okay? So really not too bad. It looks bad to begin with. Like you might look at it initially and be like, oh my gosh, this looks horrible. But they're really not going to ever be more than like two-step equations typically. So it stays pretty straightforward here. So moving ahead, we want to get that epsilon. So again, if you like to draw the lines, that's fine. If that helps you, you don't have to, but maybe it keeps everything kind of separated then. What do you want to move first? Yeah, Zach?
4.
The 4. So this is really similar to the warm-up. We're going to move that 4 over, but I'm subtracting it because the 4 is actually positive. But if I do that in the middle, I have to do that on either side. So -5 minus 4 is a -9. So there's a -2x still in the middle, and then this is 6 over here. Now here's where things get a little bit tougher. Because that -2, I'm going to end up having to divide by -2. So I have to remember that the rule still applies that I have to flip it if I divide by a negative. So since I'm dividing by a negative, I have to flip now both inequalities. And again, you don't have to write that you flipped it. I'll be able to tell. I just write that in case you're, again, not listening or something and you look and realize you did something wrong there. So 9 divided by 2, I'm just going to call that 4.5. But this needs to flip. Yikes. And it's a positive 4.5 because they're both negative. So this is going to flip. At least he's not quiet about escaping. And then we flip that other one. So you actually flip them both. Because you divide it by -2 across the whole way. All right, once we've done that, then we're ready to put this on a number line. But careful, when you put this on another number line, it doesn't always just go in the order we see it. We have to put the smallest number on the left side of the number line. So -3 is going to go over here, and then 4.5 here. So open circle at -3, closed at 4.5. Now there are special cases where from time to time, there's some kind of crazy problems where you don't end up drawing the bridge in the middle. If it's an and inequality, the ones I'm going to give you are going to be like this. I'm not going to try to trick you with that. So just a heads up on that as we do those. Okay? All right. So I think we'll break for a second. I'm going to upload this for those students online so they have a video to get going on. And then we'll do the second half after that.